we're going to do a problem. So this is a problem from the homework. And it says we have a vector field. Okay, our vector field is f of x, y, z equals e to the y, z, I hat, plus x, z, e to the y, z, j hat, plus xy, e to the y, z, k hat. And it says, is the field conservative? If so, find f so that capital F equals the gradient of f. Okay? So, well, we could have done this even in the last section. Okay, we actually did have problems very similar to this or just like this in the last section, but we're going to do it now with the idea that you need to have the curl of the vector field. And we're going to check and see if that's 0. Okay, so the curl of the vector field again, determinant I, j, k, partial with respect to x, partial with respect to y, partial with respect to z, of f, e to the yz goes here, xz, e to the yz goes here. Let me move this a little bit over. And then xy, e to the yz goes here. Okay. Let me change the color here. All right. I like that blue. That's a nice blue. So now we're going to take I hat times partial with respect to y, xy, e to the yz, minus partial with respect to z, xz, e to the yz. That's the y hat plus the j hat. The j hat is going to be partial with respect to z, e to the yz, minus partial with respect to x, xy, e to the yz, plus k hat, and the k hat's going to be partial with respect to x, xz, e to the yz, minus partial with respect to y, e to the yz. Okay, so now how do I remember that? I just think, okay, the I hat has a partial with respect to y in this. That's this first term. Minus, I would imagine going back this way, and that's these terms. Okay? The j hat has this term and this term together, minus this term and this term. And the k hat has these terms in the positive, minus these terms. Okay? So, let me just do it right over here to the side. Oops. So here we're going to have, in our I hat, we're going to have partial with respect to y of that first piece. So that's going to be x e to the yz plus xyz e to the yz. That's, and then minus, so this right here is the partial with respect to y of xy e to the yz, using the product rule. Okay, so derivative of xy is just x times the e to the yz plus the xy Derivative of e to the yz with respect to y is z e to the yz. Okay, minus, now the derivative of this with respect to z. Okay, that's going to be, or that is, x, y, x e to the yz minus, actually the minus comes from here, xz times the derivative of this with respect to z, xyz e to the yz. Okay, so you can see this cancels with this cancels with that. That's going to be 0. So far it's promising. Let's do the j hat term. Okay, this one's a lot easier actually. Derivative here is going to be what? Y e to the yz minus the derivative here with respect to x is just the y e to the yz. So these are going to cancel as well. Okay, let's hope that last one works too. K hat, partial here. So the partial with respect to x of this is going to be z e to the yz minus z e to the yz. Awesome. Okay. So, all these are 0. Okay, so we have a 0 vector. So that means the force is conservative. Now we have to find the lowercase f. So let me go ahead and do that. So, let's rewrite it. Okay. I don't think copy and paste ever works on this. Let's try. Copy. Nope. I never get it to work. Okay. Although sometimes it just randomly shows up somewhere. All right. Well, anyways, back to the problem. So we have our f, our vector field, which now we know is conservative, is e to the yz I hat plus xz e to the yz j hat plus xy e to the yz k hat. So we're going to take the integral of e to the yz with respect to x. So that's going to be x e to the yz plus, now since we did it as a function, we did the integral in x, that means we're going to have a function of y and z left. Okay, the next one, we're going to take the integral of this one with respect to y. That little pause was for you guys to fill in and test yourselves. Okay, we're going to take the integral of that with respect to y. So here, that's going to be, well, if you think about it, z is a constant, right, when you're doing this integral. So you're going to have to do a division by z. So you're going to get x e to the yz plus some new function, which would be of x and z. And the same sort of thing's going to happen here. When we do this one, the y is going to divide out. So the integral of xy e to the yz dz is going to be x e to the yz plus some function of x and y. Now, the function of y and z should have shown up here. Okay, the function of x and z should have shown up in this or this part, or both. And the function of x and y, if it existed, would have shown up in one of these two parts. Okay, so what we're left with is that our f of x, y, z is simply the xe to the yz plus a constant. All right? All right, that's it for this problem. And that's really it for this section. That's all I really want you to do.